In this video, we will discuss about the eutectic, hypoeutectic, and hypereutectic alert. Just before we have seen in the last video, we have seen the eutectic reaction and also the phase diagram of lead tin alloy. So let me draw that once more here. So that is the lead tin alloy. Here you have the lead, it is 0, and tin here. So here it is percentage tin. Here it is 100. So I told you the lead melts at 327 degrees Celsius, 327, and the tin melts at 232 degrees Celsius. And the eutectic reaction occurs at this 20, it is 80. So this is the liquidus and the solidus lines. Okay, so here you have liquid and it is liquid plus alpha. Here you have alpha, liquid plus beta, it is beta, and it is alpha plus beta here. Okay, so this is just a rough sketch of the phase diagram of lead and tin alloy. So here this temperature is 183 degrees Celsius and this composition corresponds to 62% of lead and tin, of tin and remaining 38% of lead. Now we have seen that this liquid at eutectic point at this temperature and composition, you will get a eutectic reaction. Okay, eutectic reaction. And uh, if the liquid undergoes a eutectic reaction, you will get a eutectic alloy. Okay, this is called a eutectic alloy. That is the alloy we use for soldering that melts easily. Okay, so it will be our sketch will be like this. Okay, I have drawn the detailed sketch earlier, and this portion is called beta, and this is called the alpha and beta structure. Now, suppose the transformation is carried out at a different percentage. Okay, suppose the reaction is here. So, so this is where the transformation, when the alloy is cooled at a different composition, that is from here 1 and here 2 and finally it reaches here 3. Okay, so what is happening at that? So that is called a hypoeutectic reaction. Hypoeutectic reaction, because this happens, see, here the composition is less than 62 percentage. Okay, that is less than the below the eutectic composition. So that is why it is called hypoeutectic reaction. So let us look at the microstructure evolution here. That is, see, it is from 1 to 3. So what is the microstructure at position 1? Okay, we know that it is the phase is completely liquid. So this is 1. So what happens when it crosses the liquidus line? When it crosses the liquidus line, you know that it is liquid plus alpha. So you can see that there is small crystals of alpha forms here. The rest of it will remain liquid. Okay, this is alpha, and this is alpha. Okay, so but what happens after this point? Okay, so that is the important point. That is after when it is cooled below 183 degrees Celsius, what happens? So that's the most important thing here to understand. You can see that as we move down from 1 to 2, the liquid, the fraction of liquid is just coming down. Okay, so the fraction of this liquid can be found out by using a tie line. The composition and the fraction can be found out by this line. So you can see that. See, as I come down like this, okay, finally it will come down here. So the liquid composition is just coming down and finally it reaches zero. It will be fully this alpha. See, if you look at this point, you can see that here. After that, there is no liquid composition. And this is how the composition of the liquid changes. So you can find the composition also using the liquid composition. Okay. So the finally at 183 degrees Celsius, the composition of the liquid, if you check that, it will be 62 percentage in and 38 percentage that. This will be the uh, composition of the liquid. You know that this is the eutectic composition. Okay, so this reaction at 183 degrees Celsius, this hypoeutectic alloy, there is a eutectic reaction occurring. Okay, so it will be like this. So this, this alpha will remain there. That is what formed earlier. Okay, and here you can find the lamellar structure here. Okay, so this is the eutectic mixture. This is the eutectic mixture, and this is called proeutectic alpha. Okay, this is proeutectic alpha. This is the microstructure evolution for a hypoeutectic alloy. So, right. So it is very important to understand the timeline to find the phases of this, find the composition of the phases and also the relative amount of phases during a transformation. Now let us look at hypereutectic alloy. That is hypereutectic alloy. We have discussed hypoeutectic alloy. Now, what do you mean by hypereutectic alloy? That means here the composition is towards the right, that is more than eutectic. Okay, so more than eutectic composition, that is, it is greater than 62 percentage tin. Okay, maybe some 80, 70, 63 percentage like that. This all give you the hypereutectic alloy. So let us try to predict the. Okay, let us try to predict that. So let us draw the line first. So here, so suppose it is, okay, I draw a line like this. Okay, so here from 1, here it is 2, and here it is 3. Let us look at the microstructure. For a hypoeutectic alloy, so at 1, what will be the composition? It is liquid, and it is 1, it is 2. So here you can see that some beta formation occurs. So in 2, you know that. So this is 2. Here you have liquid plus beta. So here some beta formation you can find. Okay. So this is beta. And when it crosses that eutectic temperature of 183 degrees Celsius, you can find that this composition of the liquid. So for that, you need to draw this line. See, if I draw a line like this, you can see the composition coming down. Finally, it reaches here. Okay, at 183 degrees Celsius, uh, it will reach the eutectic composition, and you can find beta, it is beta, it is beta. You can see that it is. You can find the So eutectic reaction occurs, and you can see the eutectic mixture here. Okay, eutectic mixture, and this is proeutectic beta. Proeutectic beta. So this is the microstructural evolution of hypereutectic alloy. Now, see, just for an example, we will look at the case of a hypoeutectic alloy. That is, so I will draw a small diagram here, a small phase diagram. So this is 183 degrees Celsius. So it is, let's see, so so this corresponds to 62, and let us take here this 40. 13 is 40, and so let us draw a line. This line from 1, we can take this as 2, 2, and as 3, right? So it is, here unit is alpha, here liquid, and here liquid plus alpha, and here liquid plus beta, and here beta. Okay? And here is the eutectic reaction, here you have alpha plus beta. Now, if you look carefully, what happens at this is for a hypoeutectic reaction. So here we will try to predict the percentage of proeutectic alpha. That means, so at this composition, okay, I need to find the total percentage of uh, proeutectic alpha. Okay, so for that, um, at 2, I will just draw a line here, just on the top of it. Is the top. Okay, uh, imagine that it's just over the this 183 degrees Celsius. So it is 2 here, 183 degrees Celsius. So how to find the percentage of alpha and liquids at this temperature? Okay, you can find this will be the percentage of liquid here, and this will be the percentage of alpha here. Okay, so the percentage of alpha, that is pro, that is called, the alpha form is called proeutectic alpha. This is equal to F alpha by using the lever rule. Okay, you can easily find. So that is, see, I am taking a line just above this line. So let us assume this to be 62. Okay, so this is 62, and this is 40, and this is, it is 80. So it is 62 minus 40 by 62 minus 18. So this is equal to 22 divided by 44, or is equal to 50%. So that is the percentage of proeutectic alcohol. So the percentage of liquid will be equal to the remaining 50%. Okay, the remaining 50%. Now, see, once it crosses this, okay, so once it crosses this, I want to find, see, after this line, after 183 degrees Celsius, I need to find the total alpha percent. Okay, what's the total alpha percent and total beta percent? For that, I will draw a tie line here. Okay, so it extends up to here. Okay, it extends up to here. So this length will give you the percentage of beta, and this length will give you the percentage of alpha. Okay, so percentage of alpha can be found out by, so this one is 97. Okay, it is 97 minus 40 divided by 97 minus 18. Okay, so this is equal to 57 by is 69. Okay, this much percentage. So you note that this alpha is the total alpha. Okay, earlier we found, what we found was the percentage of pro-eutectic alpha, right? So this is how you find, right? This is how you find. And if you take this point, if you look at the composition of alpha, okay, for this line, if you look the composition of alpha, this is 80 percentage, and composition of sorry, this is alpha, composition of beta is equal to 97 percentage, just below the eutectic point. Okay, so this is how you use the tie line rule to find the composition and relative amount of forces. So tie line rule is very